Hi everyone, welcome to the class. So today we'll continue from where we had left in the last lecture. We are continuing with the unit demand forecasting. So why demand forecasting is important we have discussed, but still I would like to start with an example. Now just imagine a case when there is a, let's say, a World Cup coming up, or a, there's a FIFA World Cup or a cricket World Cup coming up, and the companies are preparing their merchandise, for example the apparels, the t-shirts and all. And maybe suddenly the country which was supposed to win or had a high probability of winning loses in the initial round and walks out of the competition. So what happens to those, kind of the apparels, that is the products that are made with this World Cup, keeping this World Cup in mind? So the whole situation can become a very difficult time and a difficult situation to handle, because this had happened in several cases, and this is a real life case. In one of those years when India lost the World Cup and it was out of the World Cup, so this issue had emerged when companies who had prepared a lot of apparels and in the name of the Indian team and players and all, so they had to face the competition. Now what to do, because the market is not ready and the merchandise has been prepared with a special, for a special occasion. So in such a condition, demand forecasting becomes very important. How do you deal with demand forecasting? How do you handle a situation in such, in that case? What particularly I would like to continue and say, so there was a strategy which the company had built. One of the companies, the United Colors of Benetton, was one company which could, successfully move out of this difficult situation, and many other companies went for a loss. So what did United Colors of Benetton do? United Colors of Benetton used a strategy, right, which is called a postponement strategy. And what they did was they tried to delay each step by certain margins, so that they do not have to be at a shock in case the team that is, they want, for whom the apparel is being made, would suppose lose out, right. So keeping that in mind, and using this postponement strategy, the company could somehow minimize their losses and they could still grow. So this is a case, which is very important for us to understand that demand forecasting, a wrong or incorrect demand forecasting, can be a major cause of worry for any company, right. Your entire inventory can go for a loss, and maybe you cannot catch up to the trends in the market. So obviously you will be into a in a difficult situation. In the last lecture we had discussed about qualitative analysis of demand forecasting, and then we started with the time series analysis, right. Sorry, the trend analysis. And we talked about how time series data, for example, we said about simple moving average, weighted moving average. So kind of techniques where how do you deal with this, how do you measure the forecasting using those techniques. So today we will continue from there with some other techniques that are used in quantitative forecasting, like for example how regression correlation is used. We will see what is input output analysis, what are the various econometric models. So in fact we will not maybe talk too deep into the econometric models, but I will give you a brief how that is used, right. So let us continue with some of the other techniques that we will talk about it today. So first we will start with correlation analysis. Now correlation analysis, as we all know, is a research technique. It is basically a statistical method which helps in measuring the strength of relationship between two variables, right. And why is it important? Because let us see, if we can understand that there are two variables which are a part of any market or any any demand situation. So what is the connect between these two variables? So let us say the two variables, for example, let us say inflation is one economic condition we will talk about, and the other is, let us say, income. Now what is the relationship between inflation and income, right? Or what is the relationship between, let us say, temperature and sales, or what is the relationship between advertisement and sales? So when we are looking into two relationship, into the relationship of such variables, it helps marketers to forecast the future, the maybe the future demand in the market or future trend in the market in a little better way, right. So, as you can see I have written here, so it helps to understand situations like the effects of advertising, weather, consumer income, etc., right. So, correlation can be placed along with forecasting and through maybe an extrapolation method as we did in a in that graphical method and all. So, you can find out whether there would be a positive or negative impact, right, of these variables. So, for example, here I am saying changes in the external environment that are positively or negatively related with a firm's sales will have to be factored if you want to predict the future growth of the company. So, now let us say for example, now oil companies are all going in a very tough time, right. So, what is the reason and what is that is there any correlation between the war situation and the oil company's profitability? Now, these variables, if one does not understand, then it becomes a difficult issue for us to maybe forecast the future, right. So, correlation does not give us exactly a value like a regression analysis which we will be doing later on, okay, how much it impacts, but it does tell you the strength of the relationship, right. And if there are, let us say, a large number of variables, for example, let us say this is x1, x2, x3, x4, let us say, which all depend on y. Now, how are they related with each other, right? What kind of a correlation exists between them? Now, let us say if I can simply say, let us say all 4 variables are related for the production of y, let us say take an example. Now, if x1, x2 and x3 are there is a demand for x1, x2, x3. So, we can automatically think that x4 also would be related, because in the case of a B2B or an industrial market, we generally know that the products which have a joint demand means, that means for example, if a computer has got 100 parts or a 50 parts, then if there is a demand for computer, automatically all the parts inside will also have a demand. Similarly, for mobile phones. So, this because there is a joint demand, generally this factor plays a very vital role. Okay. Now, correlation can be seen from 3 points. One is a positive correlation when the R lies between 0 and 1. That means, any value between positive, that is 0 to 1, is called a positive correlation between 2 variables. Now, these are the 2 variables, one in the y and the other in the x direction. Now, whatever relationship is there, now for example, if the value comes, let us say 0.12, or let us say the value comes, let us say 0.39, or the value comes, let us say 0.69. So, we will say this is a very weak relationship, this is also not a strong relationship, moderate we can say, and this is a little strong relationship, right. So, the value of this R that we will calculate, where it lies between 0 and 1, it to be a positive correlation. So, this is a positive, right, this case. So, as you can see, the growth is positive. So, if one variable changes, x grows, then y also tends to grow. The second case is a case of a negative relationship. Now, you can see, as let us say y is growing, x is falling, right. So, y as it is growing, x is falling. So, this relationship is an inverse relationship. So, the value lies between 0 and -1. Okay. Now, if it is again, as I said, if it is very close to -1, we will say it is a very strong, negatively strong relationship. If it is a value close to 0, we will say weakly negative relationship, right. So, where it lies, or at a moderate one. So, where it lies accordingly, we will discuss that. The third case can be a weak or 0 relationship, right. So, look at this situation where the data is scattered. Now, if the data is scattered and here we cannot find any possible association between these x and y, then in such a condition we will say either the value of R is very weak or minuscule, which is close to 0, or it is 0, right. In such a situation, we cannot clearly determine what exactly how x is going to impact y, because they have no association between them, right. So, these are three diagrammatic representations. Now, how is it measured? Generally, when you talk about correlation, so there are two types of correlations we will talk about. One is this Pearson correlation and the other is Spearman's correlation. Now, this Pearson's correlation is used when the data is parametric in nature, right, or is a parametric study or a metric kind of data, which is generally a continuous data, right. So, in case of a continuous data, we will use this. But whenever you have a data which is not a continuous or a non-parametric data, for example, now a nominal data or a ordinal data. So, a rank, basically we talk about rank, for example. So, here we are using the other correlation method, which is Spearman's correlation coefficient. So, this is the formula which is used for a non-parametric case and this is the formula you use for a parametric case, where it is given x is the observed value of x and x bar is the mean of all the x values independent variable, y is the dependent variable and this is the observed y I we say x I, y I and y bar is the mean of y and this is how you, this is the the denominator. Now, let us look at one problem. I am not getting into both. If you want to see my lectures in marketing research in NPTEL already covers all this, but I am just giving you a brief in this case. So, let us say this is a data, right, of how much of spending. So, we feel that the amount of spending a B2B company does will affect the entire sales of the company. Now, 10, 20, 30, 35, 50, 60 up to this much, these are all spending given and this is the sales given after according to this spending. Okay. Now, suppose I want to see, I want to ask what is the relationship between x and y. What is the relationship between x and y? Now, what is the strength of this relationship? Now, if the strength of the relationship is, let us say, very high, then we can always assume that r, the x will determine, if there is a change in x, obviously y will change, right, positively or negatively, we have to see that, right. But if x and y are not related, then there is no point in discussing about taking x as a variable for y. So, let us look at this case. So, this is my spending and this is my sales, right. Now, x bar is summation of x divided by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So, 12 which gives me 59.583 and then x minus x bar square, the summation of it, right, is equal to this much. So, this is the summation. Similarly, y bar is this much 2779.167 and the summation of this one is giving me this value, right. This is for sales and this is for spending. Now, the third part of the equation was we required x minus x bar into y minus y bar. And if we do it, then you will get, I have done it in my in my notebook. So, using these values now, using these values, we have calculated using this formula r is equal to 0.9619. Now, what do we understand by when r is equal to 0.9619? So, one thing is very clear to you that this is a very strongly positive, right, strongly positive relationship. So, that means what? If r is 0.96, the amount of variance this will explain in the part of the, as a part of the study is if we calculate this as r square, if we take the r square of this, so 0.96 into 0.96 square, let us say. So, let us say understand it as 981. So, around 83 or 84, let us say 0.83 or 84 the value. So, that means what? X explains almost 83% of the change or the variance in y, this is the meaning, right. And this r square is also called as coefficient of determination, right, and it explains the variance, right, how much of variance is explained by the independent variable as a part of the dependent variable is explained by this number, right, okay. So, this is correlation, okay. So, correlation will tell you about the strength of association, how close these two products are associated. Now, if we can understand it well, so we can assume that if let us say x, let us say there are two as I had said that x1 and x2 are dependent, are affecting y, let us say. Now, if x1 suddenly there has been a demand, we can see that x1 is a product, let us say for example x1 is let us say oil and x2 is let us say lubricant. Now, for a auto manufacturer, let us say auto manufacturer comes to know, or a lubricant manufacturer comes to know that suddenly there has been a demand for oil in the market and the sales of the cars are also growing. So, automatically it can assume that lubrication demand will rise, right. So, a qualitative analysis also can be done through the by looking and observing at these variables. Okay. Now, then we come into the situation where only the degree of association is not enough. Now, there is a case where we have to predict. Now, how much is it going to impact? Now, for this situation we will use a regression analysis, which is in the simple terms called a linear regression analysis. So, linear regression analysis says uses a method which is called the least square method, and what is the least square method? I will explain that to you. First of all, linear regression is a statistical tool used to predict future values from the past values, right. Now, if you remember Box-Jenkins method, I had said Box-Jenkins, what was it doing? It was using regression method in the times for the time series data, right. But here we are talking about a normal data which we have collected. Now, we are using this from this past values, we are trying to predict the future, right. Commonly used as a quantitative way to determine the underlying trend. So, there are two variables here, so which already we have spoken, independent variable that affects the dependent variable. Okay. There can be more than one independent variable, obviously, which I have said x1, x2, x3, x4, x5, right, and there can be one dependent variable, right. So, we are not going to talk about multiple dependent variable, but we are talking about multiple independent variables at the moment. Okay. Now, take this example. Maxis is a company which is the business of selling laptops, okay, and they realize that the forecasting is very important, right. If it is rightly done and done early, it has a lot of advantages. They also realize that in order to perform, they need to keep track of the current and past sales numbers. So, how the sales numbers are performing, how they are performing, that they have to keep track of it. Currently, they are in the process of forecasting the sales number for each quarter of the coming year, right. So, in the next year, let us say this is 2022, for the 2023, each quarter they will try to find out the sales. To do this, they have pulled up their sales number for the last 12 quarters and the numbers are given to you. This is the same number that you have seen in the maybe the last case. So, sales number is the same. So, 1, 2, 3, 4, 5, 6 and 12 quarters. Now, each quarterly sales is given to you from 1st to the 12th quarter. Now, here I am saying using the least square method, we will use the least square method to forecast for the coming 4 quarters. Now, what is this least square and why it is called least square? First, let us understand. Now, least in a regression line, whenever you create a regression line or a trend line. So, what happens is, let us say this is the data, this is how the data is, let us say scattered around the regression line, right. Now, why is it called the least square? Now, because when you collect the data from the distance from each data point from the regression line. So, what happens is, now using this, if you use this, what happens is when you collect the the regression line that you have drawn now, there can be n number of regression lines, but why did you choose, let us say this is a regression line, this is a regression line, this is a regression line, these are all different regression lines, but we are only and only bothered about this thick one, right. So, we say there can be so many regression lines, but the most optimal is this regression line. Now, why is this the most optimal regression line? Now, if you collect the data and square it up, the distance from each line that presumably a line that you have drawn, and square it up the distance, that means from the regression line, that whatever the distance is coming, if you square it up and sum it, add all this data, then you will find that the minimal distance you find is for this line. So, the all the distance from of the data points for different lines, first consider this line and you collect the distances and then square it up, sum it up 1. Then you take this line as an example and do it, you take this line. So, you will find that when you take this line, this thick line, the distance is the minimum. That is why we are using the least square method, the least, the minimum, right. Now, the quarters are the different quarters are your independent variables and the sales is the dependent variable. We are using the equation y is equal to a, which is my intercept, right, and b is my slope, right. Now, what is this intercept? Again, let me show you. Now, intercept says, now if this is my regression line, intercept is this part, which says that if x, let us say, when let us say there is some amount of value, if x is 0, let us say, assume that x is 0, still you will find that y has some value, right. For example, if you do not know the sales of, let us say, t, that does not mean that there is no actually sales. So, let us say the factors that affecting sales of t is, let us say, the price, let us say one of the thing is price. Now, if I do not have the value for price, or I assume that price is let us say 0 or something, I do not know, then does it mean that there is no sales? There is, right. So, how much is that sales? That is called the constant or the intercept. So, this is the intercept. And what is the slope? The slope is this theta, right, this angle. Now, the larger this angle, the larger this coefficient of x, higher is the impact that it makes on y, the dependent variable. Okay. So, a, b, y bar arithmetic mean of all the y's, x bar arithmetic mean of all the x is the x axis value for each data point, y is the axis value, y axis value for each data points for y, and n is the number of data points. So, we will use this formula to first to calculate b, and using this formula then we will calculate a. Okay. So, what is this? Summation of x y minus n x bar y bar divided by summation of x square minus n x bar square. So, let us look at it. So, time, sales, x into y we have found out, we need x square we have found out. Okay. So, x bar is this much 6.5, y bar is 2779.17, b, now we calculate b. So, using that formula, right, this formula. So, using this formula, so we see that b is equal to, I have written this formula here also, I have put it added here. So, b is coming 359.6. Now, if b is 359.6, from here we will, assuming taking the value of y and x both their means, now we will find out a. Now, how much is that? Now, a is equal to, see, this is how it will look like, no, y is equal to a plus bx. Now, you have the value of y from here, okay, you have it, you have b, right, b is there, right, and let us put any value of x. So, now for example, for the 5th quarter, 6th quarter, 7th quarter, 1st quarter, 2nd quarter, 3rd quarter, 4th quarter, all the 4 quarters, right. So, x will be, let us say 1, 2, 3, 4 or whatever numbers you want to associate. So, 12, after 12, 13, 14, 15 and 16. This is not 17, this is 16, right. So, using this, what is this 2779? Now, a is equal to y minus b into x, y bar minus b, y bar minus b into x bar, right. So, how much is y bar? Now, y bar is, let us say 2779, okay, and b we have got it, and x bar. So, this is our equation, right, right. So, this is the equation, sorry, this is the equation, a is equal to y bar minus b, which is 359 into x bar, let us see how much it had come, 6.5, okay. So, after calculating this, so we got this a value. Now, the normal equation now will look like y is equal to a, which is 441.77 plus b, which is 359 from the last this one, into whatever x you want to determine now. So, let us say for the 13th quarter, 14th quarter, 15th quarter and 16th quarter, if you calculate, so these are the values we are getting, right. So, regression will help you to predict the value for the next quarter, right, next quarter, next time period, whatever you are trying to find out, right. Correlation was telling you the relationship between two variables. Okay. Now, after regression analysis, now we are coming to a new technique which is also very important. This technique was developed by called the input output analysis, and this technique was developed by Nobel Prize winner Vasily Leontief, right, in the year 1973. Now, what did Leontief say? He said that this input output forecasting is based on a set of relationships that explains how the output of one sector goes as an input into another sector. Now, let us say, now in the B2B for example, you see in the B2B world, you make so many people make so many companies are making so many different components, different parts and all. Now, these parts act as a part for another industry. That means my output, if I am a producer of let us say steerings, right. So, my output is an input for an automobile company, car manufacturing company or a truck manufacturing company. Suppose I am manufacturing tires. Now, these tires will go into for an OEM, they buy as a for them it is a sub part, right. So, what it says is it measures the total impact as a sum of direct, indirect and tertiary impact. Now, what do you mean by direct, indirect and tertiary impact? Now, first let us look at this. There is a car. Now, to make this car you require several parts, right, and let us say this. So, when you talk about this car, the direct effect you measure it by how much of sales is happening of cars, for example. The indirect effect is all the components, sub parts, sub assemblies that you require to make this auto or this car is part of the indirect effect. Now, what is the tertiary impact? The tertiary impact is through the maybe the service, the for example, the logistics or which is maybe directly not at all connected with the industry, but it makes a big influence on the let us say business. Okay. Now, increase in the demand for cars leads to increase in its production, right, needing for more parts and components. So, obviously, if I have a demand for more cars this year, for example, Maruti's car sales have grown up by 40%. Last year, because of poor chips, sales chips not being available, the sales was not happening, right, because COVID had disrupted the supply chain. But now, things becoming little better, the sales of cars have gone up. Even Hero Honda is feeling that there is a very big chance for growing demand. So, automatically what happens, the parts and components are also having a demand, and that also affects other service related businesses, not only this, but there could be some other businesses service. For example, you could be somebody handling your let us say inventory management system, somebody creating softwares for you. Every business now grows. So, input output analysis says that every economic condition gets affected by this input and output analysis. So, if you want to measure, you have to measure the total impact, which is this sum of this direct, indirect and tertiary impact. Because of this development, Vasily Leontief was awarded the Nobel Prize in 1973. So, he made a significant contribution by making people understand how the markets get affected by maybe due to the setup of a particular industry, right. Okay. Then you have econometric models. Now, econometric model comes from the term economics, right. So, what is this? An econometric model is one of the tool economists use, largely economists use to forecast future development in the economy. So, what would be the future development? How to forecast the future development is something that econometric models help, and economists do regularly use it. In simple term, the econometricians or economists, we can say, measure the past relationship among such variables as consumer spending. So, how consumers are spending, what is the household income, what are the tax rates the government is levying, interest rates charged by the banks, right, employment and the like, for example, similar cases. And then they try to forecast how these changes in some of these variables will affect the future course of others. Now, take this example which I have the source is given here. Now, if you look at it, every household, people living like you and me, right, are contributing to as labor to the business firms, right. So, this is the labor service that we contribute. So, you are working for an industry, for example, Maruti or Hero Honda or HUL. Now, this business firm in return gives us wages and salaries, right, second point. So, I work, and in terms of my labor, I against my labor I get some wages and salaries. Okay. Now, this salary again comes to me, and then I start spending, right. What do I do? I, as an output, the business firm makes cars or clothing or whatever it is. Now, this is purchased by the household, the people, the individuals, right. So, the money that I have received through my labor is being used to buy these particular different outputs that the business firms manufacture, right. And finally, what it is saying, payments for household purchases are done through this, so again this money that you have earned. Now, it again comes back to the business firm, for example, when you buy their products and services. So, this continuous process is a very efficient process and very important process. Why? Now, in case if any one of it gets affected, let us say there is no job, or job market gets affected and it has come down. So, people will get less jobs. So, less jobs means the business firm will have less employees means they will have less output, they can produce less, and the number of people who are earning, since they are less, so the capacity to buy also will be less, and if the capacity to buy is less, so the payment that is coming to the business firms is also less. So, this is a kind of a vicious cycle that has developed. So, in such situations, countries, governments, the economists, the finance minister, they try to intervene into the system by pumping more money into the system. Sometimes you must have seen a case where governments tend to print money. All time printing money is not a very good option, but in certain cases the government goes for printing money, right, pumping in more money into the system, so that there is more money, so people can spend, and if people will spend, automatically they will spend on those items where the production will happen, and as the production will happen, again the wages and salaries will come. So, this cycle will again go on, and it is sometimes called a multiplier effect. So, when the government tries to invest in by starting certain industries for or something, so it has a multiplier effect on the economy. Okay. So, econometric models are also used for forecasting. Okay. Let us take a case and discuss about it. Leaf Co company is a medium sized agro business firm, right, in Jharkhand in India, right. So, it produces 3 special grades of leaf pulp it is making, all of which are sold to local small scale manufacturers. And these manufacturers, now what they do? They produce food containers, leaf paper bags, and some packaging materials for the nearby markets. Grade A is primarily, so 3 grades, no. So, the first grade, the grade is A is primarily in the production of leaf paper food containers, grade B production of leaf paper bags, and the third one used for in the production of leaf paper packaging materials. So, the first one was grade A food container, grade B paper bags and packaging materials also, and grade C in the production of leaf paper packaging materials only, right. So, some packaging materials were being made by the B grade things, and mostly all the C grades are only for packaging materials. The byproducts of its pulp production processes are sold to local small farmers as fertilizers. So, now this company is producing, so it is a agro product business. So, now what is happening, the Jharkhand government recently announces a policy promoting eco-friendly products. What has the government done? The government has shown some interest towards eco-friendly products. Okay. Now, eco-friendly products are basically all agriculture natural products. So, for this reason, the marketing manager of this company expects the market for leaf paper products to grow at twice or even thrice the current rate, right, and expects that these customers, leaf companies customers, will expand their marketing operations to other nearby markets such as Bokaro and Dhanbad. So, these are 2 big cities where there are some mining and steel business, in Steel Authority of India Limited steel plant and mining is there. So, they want to expand to those markets. On the other hand, the operations cum finance manager is less enthusiastic, right, about the growth potential of the market, pointing out that the customers are small scale units. So, they would face serious capacity constraints and logistic difficulties if they try to expand to the other markets, and suggests a more cautious approach. So, what is the operations guy doing saying? The operation guy is saying that it will be a heavy pressure on the small operators, the small businesses, because they might not have the capacity to produce so much and go into the new market, but the marketing team is very happy that they see some real growth from this policy by the company, a government. So, now for this, to answer this case, first you think about it, the data is there in your hand, right, it has been given to you. Now, you decide, you look at this case and tell me how would you do the forecasting. Okay. So, now these are the different quarters, grade A, grade B, grade C. So, these are the different sales, and leaf paper food container, leaf paper packaging material and leaf paper bags. All the products demands are given and sales are given to you. Now, the quarterly sales figure of leaf company of the different grades of leaf pulp and the quarterly sales figures of the different leaf paper products are given here, right. Now, using this data, let us work on only one. So, as the data points, if you see these data points, they were close enough without much fluctuations, gradually showing an increasing trend. So, although they were increasing, but the growth was quite limited, quite slow, or quite, there was a very little growth, right. So, we decide to use simple moving average with assumption of 4 months moving average, right. So, now if we first find out the quarter fourth for 2007. So, what we will do is we will take the last 4 quarter data that is available to us. So, let us take this last 4. So, 9626, 9790, 9817 and 9918, and by divided by 4. So, we calculated this is the fourth quarter forecasted demand. Now, for 2008, so first quarter, so we will take the recent 3 which is we have and the forecasted for the fourth quarter we have added here. So, we got a new value, and similarly for the quarter 2. So, now we will take 9828. So, this 9828 now comes here and the remaining 3 we take. Similarly, for third quarter we will take the fresh value which is here 9837, and the remaining are, you have it as it is 9918, 9878, 9828, this one comes from here. So, similarly you have calculated for the fourth quarter also 9787.75, 9828. So, 9828 is here, 98787 is here, right, plus 9837 this one and 9842 this one. So, we have calculated for the fourth quarter. So, by using this method, right, what we have done is we have just brought in the fourth quarter, then incorporated into the first year of the next quarter, next year, that is 2008. Then calculating this value we have put in the quarter 2, and then after calculating this value we have used it again in quarter 3, and similarly we have calculated for all quarters. Now, we have computed for grade A. Now, your job is to compute for the rest of the 2 grades, which is the grade B and grade C. Similarly, you do the fourth quarter sales or the 4 quarter sales for the next year 2008 for these 2 products, right. So, with this we will wind up the class, because obviously we have crossed the time limit. So, thank you very much, and till then take care. Thank you very much.